I think that the presence of artificial intelligence and natural language processing in medicine will, first of all, strengthen clinical decision support. And also will, as I mentioned, will provide a more comprehensive, timely, and efficient and accurate prediction of disease.
Welcome to 20-Minute Leaders. Just sit back, relax, and learn from the leaders of today. It's a journey. Each one is different, unique, inspiring. Let's get started.
20-Minute Leaders is a proud supporter of Make-A-Wish Israel and Tech to Peace, and is in proud collaboration with Secret Chord Ventures, J Ventures, Riverside FM, Fusion VC, Birthright Excel, J Impact, Leap, Google for Startups, and Hippo, and in media partnership with CTech. Welcome to 20-Minute Leaders. This episode is with Saeed Amal, an assistant research professor at Northeastern University. Amal was a postdoctoral fellow at the Stanford University School of Medicine, where he focused on the applications of artificial intelligence to improve healthcare, especially care for cardiovascular disease. He received his Ph.D. and MSc degree in computer science from the University of Haifa and a BSc degree in computer science from the Technion. Amal has vast leadership experience in applied research from the tech industry and is a former vice president of an R&D data medical startup in the field of cardiology. His research interests are the healthcare applications with artificial intelligence, including deep learning and machine learning, natural language processing, and image processing. Saeed Amal, welcome to 20-Minute Leaders. Thank you so much for joining me today. How are you?
Fine. Thank you. And thank you for having me.
Thank you very, very much for joining my show. I'm looking forward to discussing and dissecting a little bit your own journey. Today as assistant professor at Northeastern. Previously, you've been doing some postdoc research on NLP with Stanford, which I love, of course. You were also with Dynamic Yield and Carmel Tech and GE Healthcare, and originally with a Ph.D. from the University of Haifa, which is right nearby. And so a lot to uncover, Saeed. Thank you again for being here. And I'd love to get started with understanding a little bit your own journey, venturing, from even childhood all the way into the AI and NLP space. What leads you to do a PhD in the NLP space?
Sure. So, first of all, as you mentioned, I'm a research assistant professor in artificial intelligence for medical research at Northeastern University. And I'm a member of the Roux Institute. And before that, I was a postdoctoral fellow at Stanford University in the School of Medicine, Department of Surgery. So in this period, I was focusing on the use of artificial intelligence and multimodal data for improving cardiovascular disease care, which includes early detection of cardiovascular disease, and given a patient with a specific disease, we would recommend personalized and optimal treatment for this patient, given the history of this patient. So, and then before joining the academia, I was a research scientist at General Motors, where I was focusing on replacing the rule-based dialogue system in the car and the vehicle. So, and this is, of course, using artificial intelligence for natural language processing. And this is also very important in the communication between the driver and the car. It starts by using techniques like natural language understanding and artificial intelligence for understanding what the driver needs, and then responding in a natural language response. And then I was also in General Electric, a research scientist. I was focusing on building clinical language models using state-of-the-art artificial intelligence for natural language processing, for using deep learning, where we use state-of-the-art word embedding representation that can help us in understanding and modeling the clinical language. And then using this, of course, we can provide summary about patient. It can help us in the diagnosis of a patient for a specific disease. So this is this is where I had experience in the medical research and NLP in the industry.
By the way, just to ponder for a bit about General Motors, for example, you were in General Motors 2017 to 2019. This is, I believe, right around the time that Transformers were becoming a big hit in the NLP world. This is the time where a lot of these new papers were coming out, BERT, etc. How do you compare sort of, you were living through that transition. How do you compare sort of your work, pre 2018 to post 2018? How would you think through that?
Yeah. So it was definitely starting with the Attention is All You Need paper, which is did a revolution in the domain of language modeling and the use of deep learning for language modeling, and it's mainly gave the option to understand and model language using its context and not using the word itself or a piece of text. And of course, this is as part of the Transformers, and this is like main focus of my research that I used for actually generating prompt automation, taking the user utterance and taking it into understanding of this utterance and then responding. And all was based on the actually Transformers, which are gave a huge boost for this language modeling and dialogue system.
Now, within on General Motors and GE Healthcare, I'm always curious about the real tangible impact that that integrating NLP into systems that are in companies. What is the potential impact that they can make? So maybe you can share with me a little bit about how you perceived the impact of integrating NLP and how that maybe transformed or augmented some of the processes for GM or for GE.
Yeah, so up until that period, these systems were based on, as I said, on a rule-based. So, analyzing the input and then trying to using templates for templates and rules for trying to understand what happened, like what is the request or what is the information about the patient, by using real rules which would say, I try to identify, okay, this is a procedure that happened out of a report that a clinician wrote, and then using kind of a flow, predefined flow, which would need very specific handling of each disease and each flow, and then using these new techniques which would understand the context of, as example, a clinical text context. You can understand the coding of a specific disease and how it appears in the sentences of the electronic health records. This would this research that happened in the academia gave a really great impact on the industry and the use of this research in the industry, both in the clinical domain and on the, as I said, in the conversational AI. So this is a great impact that improves actually the industry.
Mm-hmm. Now you transition from from being quite a bit in the industry and implementing NLP systems in a variety of companies, what made you transition to academia at that point? Why make that shift? Usually it's the other way around.
Yeah, so it's mainly about using the artificial intelligence. And given the large amount of clinical data available, I saw as a mission to save millions of lives of cardiovascular disease patients. And I thought that with my experience and with my knowledge in the domain of artificial intelligence and natural language processing, I could have a great impact. And as you know, in the academia, you have a more freedom of research that you can do. And also, you have collaborators. As example, in Stanford, we have the hospitals of Stanford where you can have access to the data, this big clinical, big clinical data, where you can have a real great impact. As example, one of the projects that I was working in at Stanford for predicting peripheral vascular disease using artificial intelligence and natural language processing and genomic data. These algorithms that were developed after hard work are now deployed in Stanford systems. And the surgeons at Stanford use these algorithms to get confidence on their patients, on the diagnosis that they did on their patient. And I think that this is one of the main reasons that causes this transition from the industry to the academia.
Mm. So diving in a little deeper, you're introducing us into the other topic I wanted to discuss, which was NLP in healthcare and the really tangible places where NLP can be of use today. So maybe you can touch a little bit on, sort of healthcare, some of the limitations of today's processes and how, and what are the different ways, even before diving into your own research, what are the different ways that NLP can really make a significant contribution to healthcare?
Yeah, so I think that the presence of artificial intelligence and natural language processing in medicine will, first of all, strengthen clinical decision support. And also will, as I mentioned, will provide a more comprehensive, timely, and efficient and accurate prediction of disease. And also, given a patient with a disease, we would provide, personalized treatment that would be optimal for this patient and not general treatment or medication. And then also, I think that it will provide a more efficient ways of communicating information to the electronic health record systems. One more important aspect in
if I'm delaying on what you just said, that this will allow, for example, better predictions or better diagnosis. So how does NLP really play into the life cycle of a patient? How does NLP help take a regular patient and help go through a better diagnosis phase? Where is the integration here, tangibly?
So NLP actually for understanding, electronic health records where all the information that clinicians wrote into the system. When we use NLP, it would help us understand this textual data that exists, this big data, large textual data that exists in the electronic health record, and model them and understand the context of each one of these concepts and terminology of the clinical domain. And also, once we have this, we can understand and model the history of this patient and understand, what medications, what are the pathways that this patient has, and understand, giving all the information that's available in the electronic health record to lead us to predict which patient can develop a specific disease. So it can help us, as I mentioned, also in understanding the other modalities as imaging like CT and MRI. Natural language processing can help us in better understanding of these imaging data that would also help us in the prediction process, in having the whole overview about this patient.
So if we're looking back to NLP, is it the records that the doctor writes? Is it the simple communications that the patient provides in conversational AI? So where do these new language models, how do they help us make those better predictions? Because some of the things that you mentioned, they sound like traditional deep learning models where you can take a bunch of the structured diagnoses, blood tests, different examinations, and then output a prediction. But here we're talking about taking perhaps some more of a textual conversational AI type of approach to create new insights leveraging NLP. So how does that work?
Yeah. So what happens is that, the history of the patient is sequential data. These visits are sequential. And then with the domain of deep learning and, techniques like LSTMs and that can understand and model sequential data, we can, in addition to the language models that we build, we can model this history of the patient in a way that we can understand what happened in each time step. And this way we can understand, patterns in this history and understand which pathways can lead to specific disease and which pathways can lead to adverse events. Sometimes we can use it after if a patient had a surgery, then we would like to understand, would this patient develop adverse events after this surgery? And then we can probably try and have a different treatment, have a different surgery, or maybe try to understand what is the optimal treatment for this patient. So the whole revolution and the fast evolving techniques and technologies of artificial intelligence, specifically deep learning and natural language processing is giving a great impact on the understanding of this clinical domain and helping in saving lives and making lifestyle of the patients better. And I think that what I see is like, for me, my mission is to save millions of lives of cardiovascular disease patients using these artificial intelligence and natural language processing techniques. And again, I would mention that specifically given the recent large amount of clinical data available and the fast evolving of the technologies of artificial intelligence and natural language processing, and also even image processing, would provide a more comprehensive, timely, and accurate prediction of cardiovascular disease and also other diseases.
If we're looking at the advancements of large language models, foundation models, how are they promoting, or how helpful are they in the healthcare domain? Because to me, it sounds like a lot of the healthcare domain requires a lot of specification, a lot of fine tuning. How do these larger models that are more one shot or few shot generalized models, are they relevant for healthcare, or is it more of the fine-tuned ones that are more relevant here?
Yeah, so actually what we do is we start with these pre-trained language models. But each time you need it, even for clinical domain or some other domain, you need to fine-tune it and you need to train these models to understand. If we talk about the clinical domain, you need to fine-tune it and make it understand the context of these domain. And as I said, if we talk about a specific disease like PAD, peripheral artery disease, so we would like to model the context of how this specific like code or disease appears in the sentence and in the reports, and this requires us to get the large-scale electronic health records and prepare new language models that are specific to this clinical domain. And sometimes you can also try to have, even in this large-scale clinical domain, you can also make it specific for a specific disease and build language models that fit for this for these matter.
Got it. If we're looking at regulations and, clinical data, hospitals, their willingness or their ability to collaborate and share this information for this research, is that we know it's difficult and it's not trivial. Is it a blocker sometimes, or is it just some challenge that you have to overcome, but it's trivial to overcome it?
Yes, it's a big challenge. Like this is one of the biggest challenges actually that we face, because the clinical data is has it's a very sensitive and private data, that sharing it and trying to use it even for good matters, because you use it to save the humanity. But even though this is a private information, and the process of acquiring and collecting this data is really time consuming, and sometimes a real required hard work of all the what is it called, the IRBs, and being able to have HIPAA compliant servers, and where do you save the data, and how do you process it, and how do you de-identify it. So this is definitely a big challenge, and also you need like the collaboration with the hospitals. You need to find the hospitals that would like to be engaged in research, because not all hospitals are ready for this and would like to invest this time of their clinicians and of their staff for research.
Interesting. And if we're looking a little bit ahead, so how impactful do you think this technology tangibly will be in the next few years? Sort of right now, it from the outside, it doesn't seem like too much is happening yet in the integration of NLP and healthcare, but is there a lot going on? Do we expect it to happen soon? Maybe only in 5-10 years? What is sort of your prediction of that?
There's definitely a huge amount of research happening in this area, and the universities are investing, a lot of resources on this area. As example, now in Northeastern, we are building a computational medicine center, and hiring assistant professors and research scientists to focus on this very important mission for the humanity. And I assume that all universities are also focusing on this combination of medicine and artificial intelligence, in order to be able to to deliver solutions that can save a lot of lives.
Wow. And if we're looking at academia versus private companies as catalysts for this integration and innovation, how do you see the role of academia versus private startups or companies?
Yeah, so I was actually also, as I mentioned, I was in the industry, also in the healthcare domain. It's different budget. It's different budget to engage, hospitals. Of course, in the industry, they have the money to pay for pay hospital like $1 million just to get their staff working on the project and deploying this project. This is the main difference. But on the academia, you have a lot of researchers that are ready to do this and to try and have the incentive for the hospitals to be able to to be engaged in this effort without these large scale budgets that exist in the industry.
Mm.
Yeah.
And from a research perspective, is it more that, if we're looking at what needs to happen to make a significant impact, do we already have significant technology that is ready to be implemented today and we should be focusing our efforts there? Or do we need to be focusing our efforts in the healthcare domain on further NLP research? In other words, if we had to choose where to divide our resources between, cutting edge, progressing NLP further as a mathematical domain versus the implementation and integration of NLP into the healthcare industry, where do you think we are?
I think that we are in a very critical and important place where we have the artificial intelligence and natural language processing techniques that are ready to be used in the healthcare and in the medicine domain. And this is what we are trying to use. We use these techniques, we apply them to solve problems and tasks that exist in the medical research domain. So, and I think the technologies are well evolved and are ready to be used in the medical research.
Mm-hmm. And tell me about your work as an assistant professor, Northeastern. Well, what are you doing there?
Yeah, so as I said, I'm focusing on the use of artificial intelligence and multimodal data. When we say multimodal data, it's imaging modalities like CT, MRI, X-rays, and also modalities like the textual data, which we extract from the electronic health records, and we try to model it and understand these large-scale reports that we have written long time ago and keep growing, and the modalities as genomic data for the matter of improving disease care and trying to predict adverse events. Specifically, one of the research that I'm focusing on now is how can we predict adverse events after cardiothoracic surgeries. And we have hospitals that we are collaborating with, and they are really engaged in this important effort. And also, I'm focusing on the use of this artificial intelligence techniques and natural language processing and image processing for recommending personalized treatments that would definitely help in the lifestyle and in the outcomes of the future of each one of these patients. When you try to understand, given the history of the patient, what is the best treatment, what is the best medication, what's the best surgery that he should be given, you can meaningfully improve the process of his recovery. And sometimes a lot of times it's saving his lives.
Incredible. It sounds like you're very passionate about what you're doing, and you're very clear on sort of why you're in this space. It sounds like it's coming from a very impactful part, right?
Yeah.
Was there a certain instance or reason why you sort of took on this challenge of NLP with healthcare? You mentioned in the beginning that you're doing this because you want to potentially save lives using technology, but was this always from growing up what your intention was? That's why you got into technology, or is it something that sort of shifted over time?
Well, actually, it's when I started to deal with, it started, of course, with the projects that I was working on for using artificial intelligence, natural language processing for healthcare. And then I realized how important this domain and how important this effort. And I saw it as a critical mission that I need to take on myself and pursue these types of research.
Yeah, that makes a lot of sense. And if you had to choose one thing that you're most excited about in the NLP domain or technology domain in general in the next few years, what is something that really sort of blows your mind as it's happening now?
Yeah, so I'm really interested about these language models that can be adapted to the clinical domain. As you know, you need to always be up to date with the techniques for language models. We had, and in the last few years, it was a real revolution. Like we started with the word2vec on Google, and then BERT, attention is all you need, and for transformers, and then BERT, and then GPT-3. It's like the pace is really, really.
I love it. Saeed, thank you very, very much for coming and for sharing a little bit about your passion on NLP from even before you were doing it with healthcare all the way to today. You've seen some of the really awesome transformations with the different seminal papers, but then the production of them into the industry. And it sounds like your work with academia is very much aligned with your own personal mission. And so it's very inspiring, and I'm really excited to be following your own journey and seeing the amazing impact that you're going to continue doing. So thank you very much for that.
Thank you so much. Thank you for having me.